associated with our inner ear is some organs of equilibrium. And equilibrium has to do with our position in space and also our movement in space. So if you've ever had dizzy spells or vertigo, you know how awful this can be, this disruption of the equilibrium, because it feels like you're moving when you're not. And so it's a super important organ, and we're going to take a look at it. When we see the ear, let's just go to this picture first. We see the cochlea, which we talked about, which is not equilibrium, that is actually hearing. But then associated with the cochlea, we have the structure called the vestibule right there. And then we have the semicircular canals. So the vestibule and the semicircular canals are part of that equilibrium, organ of equilibrium. So we have the vestibule and the semicircular canals. So the vestibule actually has two parts to it. It's the utricle and the saccule. And these give us a sense of acceleration. So like when you're moving in a car and you're moving forward, you have this sense of moving forward and accelerating. Really interestingly, however, though, if you, for example, are at a constant speed, then that sense goes away. Your body just responds to that and stops sending the signal that you are moving. So even when you're moving, in an airplane really fast through the sky, it doesn't feel like you're accelerating or decelerating if you're at a constant speed. So this gives us information about accelerating. And we actually have structures called otoliths. These are ear stones, otoliths, ear stones. They're composed of calcium carbonate. They're different than your ear bones, the ossicles. So otoliths are the ear stones. The semicircular canals, on the other hand, have to do with rotation. So this is rotational movement. And they are oriented in different planes. So like rotating head over heel, right? Rotating this way, rotating sideways. All of those circus rides that you might enjoy or might not enjoy take advantage of this vestibular apparatus and the semicircular canals in order to give us the sensation of whatever that sensation is of being dizzy and excited and scared all at once. Okay, so let's look at some images of these. So this is the utricle and the saccule, and they are located in the vestibule right there. When we look at this membrane, we have hair cells right here, but they are embedded in a gelatinous membrane that has then these otoliths. These are little stones. And these little stones put pressure. And so as you accelerate, they change position and they change the way that the hair cells are being bent. Even going up and down in an elevator stimulates these otoliths so that you can tell you're accelerating or decelerating in a linear or vertical, right? Vertical versus horizontal plane. Okay, so those are the otoliths. When we look at the semicircular canals, you'll notice that there's 3 of them. They're in the different planes, and they're a little bit different. They don't have otoliths, but they have these little receptors at the base of the semicircular canals. So this is a ampulla. This is my hair cells. This is at the base of those canals. These canals are filled with fluid, and when the fluid moves, they move this little gelatinous membrane, and then that gives us the sensation of moving. So when you're in position still, there is no action potentials being generated. But when you're moving in one plane, spinning, for example, that is going to change the orientation, and that bending of the hair cells is going to send an action potential to your brain that allows you to sense that you are moving. So this again is the sensation of equilibrium. If people damage these structures, it can be very devastating to their lives. You can imagine how important even this equilibrium is to standing and to walking. Both of those require our equilibrium.